In this lesson, we are introducing the concept of the unit circle. Now, before we do that, you need to understand radians because we're going to be able to convert between radians and degrees, degrees and radians. So again, it's a unit like degrees. So like here, for example, a full circle is 360 degrees or 2 pi radians. So 2 pi is the same as your 360 degrees. So again, 2 pi to 360 degrees. So then a semicircle, which is half, which is 180 degrees, or, well, 2 pi divided by 2 is pi. So pi radians is 180, or again, pi to 180 degrees. So this is the focus here when we are converting radians to degrees, because the value of pi is 180 or 180 degrees. So like here, for example, I'm converting radians. I've got pi over 2 degrees. So if I want to cancel out this pi here, right, because we've got to convert it to degrees, that means I'm going to divide by pi. So that means we're going to use the ratio in this form, 180 to pi, right? So again, this is what we're going to be focusing on using, either if we need to flip it in order to cancel out or leave it. Because now notice, right, if I were to multiply, that's just pi divided by pi. Pi divided by pi, cancel out. Now notice you just have 180 divided by 2, which is 90 degrees. So pi over 2 is 90 degrees. So again here, we're trying to convert the radians to degrees, so I need to cancel out pi, which means I need to divide by pi. So here, we're going to set up our ratio here and multiply. Pi cancels out, so now I've got 3 times 180. So that's just good old 3 times 180 divided by 4, and you're left with 135 degrees. Go ahead and pause the video and try the U-try on your own. And here we go. So again, you're converting, so we're going to have 180 over pi for pi to cancel out. So that's just 7 times 180 over 6, and you're left with 210 degrees. That's 7 pi over 6. So to go the other direction, right, we're converting the degrees. So that means we need to cancel out the degree, which means now we're going to divide by 180 degrees. Now we've got pi to 180. So now in here multiplying, now I've got 60 pi over 180, because this is like 60 over 1. Then, of course, simplify, and you're left with pi over 3, because this is 1/3. So pi over 3. That is 60 degrees in radians. So again, we're converting the degree, which needs to be canceled out here. So we're going to write it and divide by 180. So we've got pi to 180. So this is 240 pi over 180. So you can simplify this in the calculator as well, and you are left with 4/3. So here, 240 degrees in radians is 4 pi over 3. Go ahead and pause the video and try the U-try on your own. And here we go. So again, you're going to multiply. So since I'm out of space here, so 315 degrees times pi to 180, so that we can cancel out the degrees here. So now simplifying, 315 pi over 180. Simplify that fraction to 7 over 4. So 315 degrees is 7 pi over 4. That is the amount in radians. So now we're going to get into the unit circle, but before we do that, we need to understand how to read it, because right now, here's the image here, can look pretty complex. So we're going to go back and talk about and use our 45, 45, 90, and 30, 60, 90 to identify the ratios and then identify the parts in the unit circle and how to read it. We're going to use a hypotenuse is 1, because ultimately the unit circle, if I wanted to draw a right triangle, so like here, if I wanted to draw a right triangle, notice how the hypotenuse is the radius of the unit circle. And if it's a unit circle, right, then that means that's just 1. So the unit circle has a radius of 1. So keep in mind, that's why we're going to set the hypotenuse here to 1. So go ahead and pause the video and identify the 2 legs on your own for part A. And here we go. So this hypotenuse should be in the form of radical 2. So this is just 1 is equal to x radical 2. So let me switch it. So 1 is equal to x radical 2. Then we solve for x dividing by radical 2 here. Then x is equal to, we need to rationalize, right? Multiply by radical 2. So this is radical 2 over 2. So if one leg is radical 2 over 2, then the other leg is also, right, radical 2 over 2. So that's our 2 legs here with a hypotenuse of 1. Then if the hypotenuse is 1, then remember the short leg is half of that. So that's just 1/2 or 0.5. But notice we're dealing with fractions in the unit circle, so we're going to leave it 1/2. Then the short leg is half the hypotenuse. Then we take the short leg and multiply it to get the long leg by radical 3. So this is 1/2 times radical 3, or this is radical 3 over 2, because that's just 1 times radical 3, which is radical 3, 2 times 1, which is 2. So we'll rewrite this as radical 3 over 2. So now go ahead and pause the video and do part B. Identify sine of 45 degrees, cosine, and then sine and cosine of the 30 and 60 here. And here we go. So I've got sine of 45 degrees. So remember, sine is opposite over hypotenuse. Well, opposite, it really didn't matter, right? Because they're both the same. So the opposite was radical 2 over 2, but then divided by the hypotenuse, which is just 1. So any number divided by 1 is just that value. So sine is radical 2 over 2. Same thing for cosine. Cosine is adjacent over hypotenuse. So technically you should have gotten the same thing, because that's radical 2 over 2 divided by 1. So still radical 2 over 2. Then sine of 30 degrees. So sine is opposite over hypotenuse again, right? So this was 1/2 divided by 1, which is just 1/2. Cosine is adjacent now. So adjacent is radical 3 over 2 divided by 1. So just radical 3 over 2. Then sine of 60 degrees. Well, opposite is now radical 3 over 2 divided by the hypotenuse of 1. So leave it. And cosine adjacent. So that is 1/2 over 1, which is just, again, 1/2. So now that we've got part B, now we're going to look at the unit circle. And I want you to identify these 3 values and the corresponding coordinates. So like, for example, we're going to locate 45 degrees. So 45 degrees is right here. What are the coordinates corresponding to 45 degrees on the unit circle? Right here. So 45 degrees is radical 2 over 2, radical 2 over 2. That's your x and y coordinate. Go ahead and pause the video and identify the 30 and 60. So here for 30 degrees, you should have identified this coordinate here. So this is radical 3 over 2, 1/2. Then for the 60 degrees, right here, here's our coordinate. So 1/2 and radical 3 over 2. So now I want you to pause the video and see part D. What you notice is the relationship between the trig ratios here So for the 45 and the coordinates, the 30 and the coordinates, for the 60 and the coordinates. And here we go. So what you should have noticed is now it's difficult to see for the 45 because everything is the same, but they match, right? What do you notice though? Now you can see with the 30, 60. What did you notice for the 30 about the X and Y coordinate? The X coordinate was the cosine of the 30 degrees, and the Y is the sine of the 30 degrees. So does it match here? What is the X and Y? Well, 1/2. That was the cosine. There you go. And the Y was the sine. So that is the relationship. So if we are looking for sine or cosine of a given degree on the unit circle, the X coordinate is cosine and the Y is sine. That is our pattern here. And this is how we're going to identify sine and cosine of the degrees on the unit circle. So again, if you think about it, it's just right triangles, but plotted on the coordinate grid using the unit circle with a radius or a hypotenuse of 1. So like here, so again, right? So I'll rewrite this so that we remember X and Y. So your X is cosine, your sine is Y. So if I want to know sine of 135 degrees, so again, sine is Y. So we need to first find 135 degrees. So here's 135, but we just need the Y coordinate, which is radical 2 over 2. That is the sine of 135 degrees. So cosine of 11 pi over 6. Now, it's on the coordinate grid, but on the unit circle, but let's just say, for example, it wasn't given to you. How do you convert? So again, we're canceling pi, so pi needs to be in the denominator. So 180 up top. Canceling out, and now multiply. 11 times 180 divided by 6, and we're going to look for cosine of 330 degrees. So now cosine is the x coordinate. So we're going to find the x coordinate of 330. So here's 330. What is the x coordinate? Radical 3 over 2. That is cosine of 330 degrees. So go on and pause the video and try the U-try on your own. And here we go. So you're looking for sine. So sine is the y coordinate. So looking for 270, which is here. What is the y coordinate? -1. That is sine of 270 degrees. Now, tangent is a little tricky because tangent is always, if you recall, tangent is opposite over adjacent. So if you think about it, this is sine. Sine was always opposite and cosine was the adjacent. And then of course the hypotenuse for both. So this is tangent in terms of sine and cosine. Tangent is opposite over adjacent, or sine over cosine, or what was sine? Y. Y over x. So again, tangent is sine over cosine, which is the same as y divided by x. So now we're going to use the whole coordinate. So like for example, tangent of 60 degrees. So here we're going to locate 60 degrees on our coordinate, on our unit circle. 60 degrees. Here's our coordinate, right? So we've got 1/2 and radical 3 over 2. So now we're going to use the coordinate to find tangent, which is y divided by x. So the y is radical 3 over 2 divided by x, which is 1/2. Now notice, you are dividing fractions. So if you recall, you need to multiply by the reciprocal, or if you've heard in the past, keep, change, flip. So we're going to take that radical 3 over 2 and multiply by the reciprocal. We're going to flip 2 over 1. So now notice here, 2 divided by 2, canceling out, and you're just left with radical 3 over 1, which is just radical 3. That is tangent of 60 degrees. So keep in mind, we need y divided by x. So let's do b. Now again, let's practice, right? So here, how would you convert? Well, if you're converting and you've got pi in the numerator, pi needs to be in the denominator to cancel out. So now I've got 180. Then pi cancels out, and you've got 5 times 180 divided by 6. And you should get, we're going to look for tangent of 150 degrees. Now we can check 5 pi over 6. There you go, 150 degrees. So we're going to use our coordinate here. So we've got radical 3 over 2, 1/2. So again, tangent is y divided by x. So we've got 1/2 divided by radical 3 over 2, or we're going to keep here, and we've got 1/2 times the reciprocal, 2 over radical 3. So again, notice how the 2's cancel out, 2 divided by 2, and now we've got 1 over radical 3. However, we're not done, because why? We have a radical in the denominator, which we cannot have, so we need to rationalize by multiplying by radical 3. So now here we've got radical 3 over 3. That is tangent of 150 degrees. And again, for that reminder, here, remember, right, they cancel out because this is radical 9. And the square root of 9 is 3. And radical 3 times 1 is radical 3. Go ahead and pause the video now and try the U-try on your own. And here we go. So we've got 135 degrees, so tangent of 135. So here is, oops, sorry, you've got 135 degrees. So we're going to look for tangent using our coordinate here. So our coordinate is negative radical 2 over 2, radical 2 over 2. Then here I just realized, and my apologies, this was in our example that we did previously. That was a negative here, I apologize. So it ends up being negative radical 3 over 3. So now here we're going to take our y and divide it by our x. So this is radical 2 over 2 divided by negative radical 2 over 2. Or again, we're going to multiply by the reciprocal. So radical 2 over 2 times negative 2 over radical 2. So notice how here they all just cancel out because that's 2 divided by 2, which is just 1. Radical divided by radical 2, which is just 1. So this is negative 1. That is tangent of 135 degrees.